Okay, you should be able to see some questions regarding the VIP material. The questions are addressed to Adrian. So does VIP lose its effectiveness over time if the vacuum panel leaks and loses its vacuum? And what is the lifespan of the product? Is the first question. Then what is the performance of the VIP around the edges of the panels? Is there significant thermal bridging losses at the edge of the panel where there is no vacuum?
Okay, shall I start with the first?
Yeah.
The first question.
Adrian, sorry, just my suggestion to if you can answer them all in a row, since we're already beyond our time schedule. So
well, I'll just take two questions at a time then.
No, you can. I would suggest that. I mean, most are related, so you can just ask them all together if you want.
Okay. Trouble is, at the moment my screen is scrambling and I can't see any of the questions.
Oh, okay.
That's the issue I've got. So I was just trying to remember them as your colleague was reading them out to me. Yeah, I've just got a scrambled view at the moment of the desktop.
Strange. Okay.
Shall I repeat the question for you? Then you can answer.
The first question, I can remember what the question was, and it was regarding does the thermal performance reduce as it loses vacuum? And the simple answer to that is yes. Without the vacuum, the thermal performance would be around 20 milliwatts, and so over time, if the panel is punctured or damaged during the installation, then it will slowly lose its vacuum and thus its thermal performance will revert to that 20 milliwatts once the vacuum is exhausted.
Very good. And then the next question was, what is the performance of the VIP around the edges of the panels? Is there significant thermal bridging losses at the edge of the panel where there is no vacuum?
There is a difference between the thermal performance at the center of a panel and at the edge of the panel. Some products use an aluminium foil, which gives good barrier but actually gives quite poor edge effects. We use a metallized polyester material, which reduces this effect significantly. And the aged values I was talking about before of 7 milliwatts, that accounts for any edge effect through the VIP. So that's why we use the value of 7, whereas actually the center of the panel could be 4, 4.5, but with aging and edge effect, the declared value goes to 7 milliwatts, and that's what we use for doing our calculations.
And what is Optim Air panel made of? Does it come from petroleum or from natural materials? How does it react to fire?
We're currently testing the fire. The core is completely non-combustible. So it's made from fumed silica, which is a derivative of sand, and there are other ingredients in there which make the core non-combustible.
How do you avoid high U values at the edges?
I think that's the same question as before, really. Yeah.
Okay. And if we can believe in an R value of 6 with Optima VIPs, how are the connections between panels dealt with? Are they and thermal bridges between panels?
Okay. No, what we do, our products are very, very squarely manufactured, so they butt up quite nicely to each other. So we create minimal gap between each panel, and there are also techniques where you can overlay panels so that the joints don't align. But as I say, the 7 milliwatt value takes into account these figures, so that the correct thickness is then used to create the U value that you desire in your application.
Okay. Then we have at least one clearly question for Mr. Bristow, and one that can be answered also more generally. So to Mr. Bristow, how does Change in Street scheme work with financial need of owners? Is there any council co-participation, national programs, or other European, for example, programs?
Yeah, the good news for the maintaining street scheme was it was all fully funded. The council obtained funding via something called the Regional Housing Board. So there was no contribution from the owners. Excuse me. Unfortunately, that funding's now ended, and as I referred to in my presentation, the only funding available for these sorts of schemes at the moment is something called the Green Deal, which comes through the Energy Act 2011, and something called the Energy Company Obligation, whereby the utility companies have an obligation to carry out energy efficiency works. Unfortunately, that funding is quite limited, and what we're seeing already is that the quality of the work is suffering because the funding's tight, and the contractors, the utility companies or their contractors are cutting corners. European funding, as far as I'm aware, we have not accessed any European funding. The only funding we've accessed is through national government and regional housing programs.
Mm-hmm. And how is a holistic approach designed to success on warm Mediterranean climates? Are there any case studies that show good results on those?
Not as far as I'm aware. It's very cold where we are most of the time, so I would imagine that the principles are the same. I mean, one of my opening gambits was the fact that this presentation wasn't so much about energy efficiency. It was all about delivering whole streets, whole community programs. So the principles are pretty much the same wherever you are. It's about engaging with your owners, your community, bringing in as many partners as you can, identifying people who can deliver, and building that sort of team that can bring the improvements, a truly holistic approach to it. So not only do you do the energy efficiency works, for example, but you may address community issues in that particular area.
Okay. Let's see some more general questions. What are the measures that should be taken in countries that do not have access to technology? Whoever feels like answering.
I think these are more for David probably, and possibly David, you might want to add something to the previous question for the Mediterranean climates as well.
Okay, can you hear us? In relation to the countries that don't have access to technology, I mean, there are many passive measures you can adapt. So, and it entirely depends upon the case and climate that you're associated with. So, with a cold climate, there are natural installations you could utilise. For example, straw, and the biggest thing I'd say is improve your air tightness, and that can be done very, very simply by using non-permeable materials and around the edges of openings to your building, such as windows and doors. In terms of also, if a building is going to be modified, in a hot country, you want to maximise the flow of air through the building, so ensure that there is a direct route for the air to move throughout the building. In terms of question 2. So this is, I'm assuming this is question 2. I'm assuming that is to do with heat recovery. Safa.
Yeah, it's Safa here. Heat recovery technology is, well, a number of companies now produce heat recovery systems, but one company, really interesting, developed a whole roof heat recovery ventilation, just a local company here. And the idea is very simple. You use polycarbonate heat exchanger, very, very simple, and you could line the roof with that, and you could provide ventilation, heat recovery for the building at very low cost. And it's developed by a builder who had no knowledge at all about technology, just simply come with the idea and demonstrate in the building. So you could do that. The key about heat recovery is air tightness. So you have to build the building has to be airtight, means all the gaps and seal around windows, joints. Otherwise, the system will not function properly. So heat recovery key is air tightness, so you control amount of air in and out. So that's important. So in terms of what else improve why they use duct technology. Now, the other thing which is very important, heat recovery application be widened by look at room heat recovery rather than whole house heat recovery, because quite complex to have duct system all around the building, and that's very expensive. So there are now room heat recovery technologies which cover just for example, bedroom have its own unit, bathroom, each unit have a very simple box. You could install it in each room, and that amount you can control the heat recovery for each room rather than whole house approach. Overall saving, well, depending on the type of heat recovery, you could save up to 60% or 50%, depending on whether you cover latent and sensible heat or just sensible heat. There are technology, variety technology. Some do both latent heat, sensible heat, but of course this is this means any water vapor in the building could recover that, so heat loss. So that if you go heat recovery for latent and sensible heat, talk about could be up to 80%. Just sensible heat could be down to 50% or 40%, depending on the type of heat exchanger. What else now? Next.
Alexander, I'm a bit confused over what is requesting question 3. So I'll skip that one. In terms of construction quality.
Sorry, David, I think that was a continuation of a previous question we had to do with the selection of materials and company, but
right.
It was submitted later.
Right, okay.
If you want, you can answer it or skip it, depending on information you can provide.
Well, in terms of the installation which we select for the retrofits, a lot of that will be predefined dependent upon the partners we're working on. I mean, with respect to the HERB project, we're in a unique situation in the UK where we have an insulation provider, being Kingspan, an insulation installer, being this company called the Mark Group, the largest UK installer of insulation, and we have a housing provider, which is a social housing organisation called Leicester Housing Association, and they have houses all over the area. So, in terms of the products we use, they'd be limited to that sphere. Is Safra again?
So, in terms of insulation building, is really the key is to find a very thin insulation material, because, as I mentioned in my presentation, if the building insulation is thick, means you have to alter a lot of factors, like the doors, you have to alter the windows, so you have a big job. And so we talk about anything nanomaterials, very thin insulation. That will be very, very easy to do. For example, if you use thin insulation, you could say nanomaterial like aerogels or VIP. That means you don't have to really make major alteration in the roof structure of the building. And I know a number of people try to use standard insulation, and they've been building a house around existing house, basically building as another house surrounding their current house. So that'd be very expensive. It's easier to build another house rather than basically insulate with thick insulation. And for example, if you use straw bale, we talk about you need 0.5 meter thick wall around the existing house, which is not viable. So that is the key, very thin insulation. And there are now a number of nanomaterials, nano starch, nano gel. The cost a bit high, but the price will go down as wider application of the technologies. We work on nano starch material at Nottingham, and that hopefully we hopefully within the next year or two we have something we could get into market. Okay. Next one.
David,
Okay.
David, can I add something else?
Yeah, go ahead, Walter.
Yeah. About there's a question also about ventilation duct technology in question 2. And in the Netherlands we have done some experiments in retrofitting. We also use heat recovery, and there are quite a few concepts to introduce ductwork into retrofitting. And maybe this can also be interesting to apply in other countries. So this is what I wanted to add.
Okay, great. Okay, so in terms of question 4, construction quality, I agree that would be a very critical factor for success. Now, the Mark Group, the installer who we have working with us in the project, are the largest one in the country. They've been installing insulation for over 30 years. We have a number of standards which are followed within this country. Obviously, we have the building regulations which specify certain requirements in relation to anything constructed or installed, be that energy efficiency or in terms of airtightness, etc. And in relation to warranties for insulation systems, we have a board called the British Board of Agreement, and they specify standards for any installed system. So once it's installed, an inspector will be invited to come out, inspect the quality of the installation, and then sign a form which then verifies the warranty of an insulation system installed. So the company that are involved in the project have a very high experience. In terms of question 5, Safa is going to answer that.
Okay, regarding Mediterranean climate, really the key for warm climate is cooling. That is the key. Building insulation is of course important, and the fabric and the glazing. But the key is very simple, local, efficient technology for cooling. And to mention that we have done a number of these projects on cooling technologies. For example, we work with Chinese companies and also the UK companies on developing cooling system. And these are very simple base evap cooling. We have one technology use a core, a very simple core made of paper. They don't want to use fibers. We developed the two cooling technologies, which allow to provide very efficient cooling and very comfort climate. So this is the key. In terms of windows, another issue, because hot climate, even apply to cold climate, to minimize heat gain. And so if you have design window with a U value of 0.4, 0.3, you cut a huge amount of energy on the heat gain. But also there are some technology which are coating technology for window where you could reflect the energy, the heat from the window. And now a number of US companies develop a window which you could have reflective material. You could turn it around summer. You could use it for reflection, and winter you could use for heat gain. So you can swap it around, and there are products on the market now. I think that in terms of examples, really not much example. I haven't come many examples about good result. But now maybe because the energy efficiency in some Mediterranean countries, now looking at Turkey and some of the other Middle Eastern countries, they are looking more into energy saving. But I haven't seen many good examples to explain here. Next question about state-of-the-art aerogel for insulation. Now, we have very comprehensive paper published in low carbon technology on state-of-the-art aerogels, and cover all aspects of aerogel systems. And I'm happy to share that by email with you. I mean, you could look at my name and one of my students. We provide the most comprehensive paper on aerogel state-of-the-art, and a number of papers being published in conferences like International World Conference on Sustainable Energy Technologies. And you could look at, just search my name, you could see a whole range of papers. This is an interesting area. The key is the aerogel is the cost. It still is £2,000 a cubic meter, which is very expensive. Now, BASF just launched a new type blanket, aerogel blanket. But that just last month was news about launching a new aerogel materials. Still the cost high, so we need really more companies to start manufacturing the material. Okay, thank you.
Thank you, everyone. We greatly exceeded the time for the webinar, but I think that it was worth it in terms of the questions. Walter, would you like to do a closing, or we just end the webinar here?
Yeah, okay. Can you hear me, Alexander?
Yes, you're live.
Okay, I want to thank everybody who stayed, the still 75 participants, for your attention, and I hope it will be an interesting website and webinar, and maybe in the future we can show some results of the demonstration project here on a build-up webinar. So thank you all for your attention.